Hello, today we're going to talk about other types of inequalities, quadratic inequalities that we're going to focus on. So when you look into section 1.8 in the textbook, you're going to see we're only going to cover one section of it this time. We're going to come back later on and get the rest of 1.8. Today all we're going to talk about is solving quadratic inequalities. To solve a quadratic equality such as x squared minus 2x minus 3 is less than 0, you can use the fact that a quadratic or any polynomial can change signs only at the zeros. The x values that make up the quadratic or polynomial equal to 0. Between two consecutive zeros, a polynomial must be entirely positive or entirely negative. This means that when each real zero of a polynomial are put in order, they divide the real number line into sections. We're going to check those intervals to see which intervals make our inequality true. The zeros that we're looking for here, we're going to call those our key numbers. And those key numbers are going to create test intervals. For example, the polynomial x squared minus 2x minus 3 factors into x plus 1 and x plus 3. If we set each of those factors to equal 0, we find out the x plus 1 equals 0 gives us the 0 of x equals negative 1, and x minus 3 equals 0 gives us the 0 x plus 3. So what we've done is we've taken this infinite number line that goes from negative infinity all the way to positive infinity, and we've broken it up into three sections. One interval goes from negative infinity up to negative 1. The next interval goes from negative 1 to 3, and the final interval goes from 3 to infinity. I do want to point out that the problem that we're dealing with right now is less than. So because it's less than 0, that means the included zeros of negative 1 and 3 are actually not included in this particular solution. And that's why when you look at this graph here, you'll notice they put parentheses around the negative 1, both going to negative infinity and increasing, as well as parentheses around the 3 that's going to go from 3 back to negative 1 and from 3 to infinity. So we're only using parentheses in this case because this particular inequality did not have an equal sign. It was only less than. So what's happened here is breaking up this interval into three pieces has created three test intervals. We've got an interval from negative 1 to negative infinity to negative 1, another interval from negative 1 to 3, and a final interval from 3 to infinity. So what we'll do from this point is choose a number in each of those intervals to see which ones are true. Okay, so we had an interval from negative infinity to negative 1. We had an interval from negative 1 to 3. And we had another interval from 3 to infinity. So here's what we're going to do. We're going to test a number. And it doesn't matter what number you pick. Any number that falls on the interval. And see if we get a true statement or not. So looking at negative infinity to negative 1. Well, a number between negative infinity and negative 1 might be, say, negative 2. So I'm going to choose negative 2. And when I do that, I have negative 2 squared minus 2 times negative 2 minus 3. Well, negative 2 squared is 4. Negative 2 minus 2 is plus 4 minus 3. So we have 4 plus 4, which is 8, minus 3, which is 5. And of course, 5 is positive, but remember, we want to be less than 0. So 5 does not satisfy that, which means there's not any numbers in the region or in the interval from negative infinity to negative 1 that will satisfy this inequality. Now let's choose a number between negative 1 and 3. Now you can choose any number you want, but I'll tell you one thing I like to do. If I have the opportunity to choose 0, well, I'm going to. So if I choose 0, I would have 0 squared minus 2 times 0 minus 3. Well, that gives us negative 3. Well, negative 3 is clearly less than 0. So negative 3 satisfies my inequality. Therefore, the interval negative 1 to 3 is in fact true. Now let's try the last interval. We're going to choose any number from 3 to infinity. Again, we don't want to choose the endpoints, so I'm just going to choose 4. And guys, you could choose any number you want. If you wanted to choose 27 because that's your favorite number, it doesn't matter. It's in that particular area. So choosing 4, I've got 4 squared minus 2 times 4 minus 3. Well, 4 squared is 16 minus 8 minus 3, which also gives me 5. So which is positive? So 5 also does not satisfy my inequality of being less than 0. Therefore, the only interval that satisfies this particular inequality is the interval from -1 to 3. This next slide actually shows a graph. It doesn't show a graph. One second. Okay, we'll graph one later. So finding test intervals for polynomial or quadratic. To determine the intervals on which the intervals of a polynomial are entirely negative or entirely positive, use the following steps. And this is what we've gone through already. Step number 1, find all real zeros of the polynomial. Arrange those zeros in order from least to greatest. Those zeros, your key numbers, are going to separate or break up your infinite interval into pieces. That's step number 2. Step number 3, choose one value, and it doesn't matter what value you choose again. Choose one value in each of those intervals, plug them into your original inequality, and see if you get a true statement or not. If you get a true statement, then every single number in that interval will in fact be a solution. If you get a false, then there's not a single number in that interval which will provide a solution. We're going to solve x squared minus x minus 6, which is less than 0, and then graph the solution set. So this is the one that's going to graph. I got ahead of myself just a while ago. Well, the first thing we want to do is find the solutions to the related equation. So if I have x squared minus x minus 6 was equal to 0, I could factor that. Two numbers that multiply together to get -6, but when I combine them, I get -1. And those two numbers would be -3 and 2, because -3 times 2 is -6. -3 plus 2 is -1. So this polynomial factors into x minus 3 times x plus 2. Those are the factors. Those factors produce zeros at x equals 3 and x equals -2. Putting those in order from least to greatest, we have -2 and 3. So what's happened here is we've got this number line. I'll just put a 0 on there somewhere. I'll put 3 over here somewhere, and I'll put -2 over here somewhere. So we have broken this number line into 3 pieces. We have the interval from -infinity to -2. Excuse me. We have the interval from -2 to 3. And we also have the interval from 3 to infinity. So what we need to do now is choose one number from each of those intervals to see which satisfies. All right? I'll put a close parenthesis there, an open parenthesis, a parenthesis here. And again, I'm using parentheses to break up this interval because there is no equal sign in my original problem. Had this been less than or equal to, then of course I would have used brackets instead of parentheses. Okay, so choosing a number less than between -infinity to -2. Let's go with -3. So -3 squared minus -3 minus 6. Let's see what we get. That's 9 plus 9 minus 6. 18 minus 6 is 12. So over from -2 to infinity, everything over there is in fact going to be positive. So I don't want positive. That's not the region that I want because I want less than 0. Choosing a number between -2 and 3. Again, I'm kind of fortunate here. I can actually choose the number 0, so I'll plug 0 in. we have 0 squared minus 0 minus 6, which is negative 6. Negative 6 is, in fact, less than 0. That is a true statement. So this is, I'll put a negative sign right there. This is a region that satisfies my inequality. And finally, choosing a number greater than 3, I'll just choose 4, which would give me 4 squared minus 4 minus 6. That would be 16 minus 4 minus 6. So that's 16 minus 10. So we're at 10, which is positive. So again, that area does not satisfy my inequality. So the only region that actually satisfies my inequality is this region from negative 2 to 3. So negative 2 to negative 3 would be the interval on which the solution to this inequality falls. In each test interval, choose a representative x value and evaluate the quadratic. I've already done that, folks. And again, here is the graph. Choosing negative 3, they chose 0 and 4 as well. And you can see what the graph looks like. A little bit more detailed graph. The only area that is shaded is between the negative 2 and the 3. And you can see again, we use parentheses here to indicate that equaling 0 is not an option. We're only looking for regions that are less than 0. So to write the answer for interval notation, the interval on which the solution to this inequality falls is the interval negative 2 to 3. As with linear inequalities, you can check the reasonableness of the solution by substituting x values into the original inequality. For instance, to check the solution found in example 1, try substituting several x values from the interval negative 2 to 3 in the interval. Regardless of which x value you choose, the inequality should be satisfied. I'm not going to go through doing that right now. I'm sure every one of you can plug numbers into an inequality. But any number that you choose between negative 2 and 3 should result in a number which is less than 0. You can also look at a graph to check the example. Now, instead of having the just 0 or whatever comparison, you could, if you wanted to, sketch the graph of y is equal to. And so here's a picture of that graph on a coordinate grid. And you'll notice that when this quadratic is graphed, it is actually below the x-axis from negative 2 to positive 3. Well, those are all the points that satisfied our inequality. So that was where the solution was. So this is just another option that you could do. If you know exactly what that graph is going to look like and you feel comfortable sketching it, you can actually sketch the graph going through your zeros or touching your zeros if it's a double zero to see where those solutions might be. So this is just another tool if you don't want to plug in numbers. And folks, that is actually the end of 1.8 for the quadratics only. Relatively short. I'm going to go ahead and do the practice problems, but if you would, stop the video at this time and work them yourself, and then come back and look, and let's see how you've done. Okay, practice 1 of 2 says, solve the inequality, write the answer in interval notation. The quadratic they give me is 2x squared plus 4x is less than 0. What I'm going to do is I'm going to solve the related equation to find the key numbers to break up my infinite number line. Looking at this quadratic, it looks to me like the only thing I can really do is factor out alike terms. So I've got 2x in common. Factoring out a 2x leaves me with x plus 2 equals 0. Setting those factors equal to 0, I have 2x equals 0, and I have x plus 2 equals 0. Well, this obviously x is 0, and this one here gives me x equals negative 2. So in order, my key numbers are negative 2 and 0. Now, the one we did as practice when we were going through this lesson, we were graphing and plugging test points. And I mentioned that we could also do this by sketching, if you will, a rough graph of what's going on. So since I did the one during the lesson the other way, I'm going to do this one by sketching a graph, but I don't care about the y-axis. So here's where 0 is. Negative 2 is over here somewhere. So those are the 2 points that broke up my number line. So if I look at this quadratic, I see this is 2x squared plus 4x. If I was to graph 2x squared plus 4x, my leading coefficient 2 is positive, so I know the parabola is going to open up. The 2 also makes it skinny, but you know what? I really don't care about the shape of this parabola. All I know, this is a quadratic, it opens up. And I can draw any parabola I want that goes through those points. It doesn't matter if it's super skinny, super fat, whatever. Just draw that parabola. Now, looking at that parabola, notice the problem says, okay, where is this graph less than 0? Meaning, when is the graph below the axis? Well, it's below the axis right here. And there's no equal sign. So let me go ahead and write the answer to this question on the graph. There's no equal sign, so I'm going to put an open parenthesis there, an open parenthesis, a closed parenthesis over here, and I'm going to shade in between. Now the question says to write the answer in interval notation. So the interval on which we have graphed, or the interval on where the solution is from, open parentheses, negative 2 to 0. And there's the answer in interval notation. And the last problem to look at says solve the inequality, write the answer in interval notation. Okay, so we have x minus 3 squared is greater than or equal to 1. Well, we need to set this to 0 to be able to do this correctly. So what I'm going to do is I have x minus 3 squared. I will subtract 1 from both sides, and that's greater than or equal to 0. I will now multiply x minus 3. So x minus 3 squared, well, it's a perfect square trinomial, so it's going to be x squared minus 6x plus 9. So that is the first part here. And let's go ahead and add that minus 1 on there. Can't leave it behind. Combining like terms, I get x squared minus 6x plus 8 is greater than or equal to 0. So I've converted the inequality they gave me to a quadratic. Taking this quadratic, this now set to 0, I'm going to solve the related inequality. So I've got, or the related equation, I have x squared minus 6x plus 8 equals 0. Two numbers that multiply to 8 but combine to negative 6 would be negative 4 and negative 2. Negative 4 times negative 2 is positive 8. Negative 4 plus negative 2 is negative 6, which means this factors into x minus 2 and x minus 4 equals 0. Set each of those factors to 0 gives me x equals 2, x equals 4. So I have broken up my infinite number line into 3 pieces. There's 2, and there's 4. So there are the 3 pieces. I go from negative infinity to 2, and then from 2 to 4, and then from 4 to infinity. So I will do some test values, and I'm going to actually test values into my original equation. So number less than 2, let's go with negative 3. So I have negative 3 minus 3 squared. Let's see what that gives us. Negative 3 minus 3 would be negative 6 squared, which is 36. 36 is greater than or equal to 1. So in this area here, we have a true statement. Choosing a number between 2 and 4, I'm going to choose 0. 0 squared, which is 0. Is 0 greater than or equal to 1? Nope. So this is a false statement here. So I know my solution does not fall between 2 and 4. Choosing a number larger than 4, let's go with 5. Gives me 5 minus 3 squared. Well, 5 minus 3 is 2. 2 squared is 4. 4 is, in fact, greater than or equal to 1. That is a true statement. So on this particular problem, I actually end up with 2 intervals that are true. I also want to point out again, this problem actually has greater than or equal to. So because of the equal to, we've got to include the point that's there. Okay? So we're going to shade from negative infinity all the way up to 2, and this time this would be a bracket, and then from 4 up to infinity. So there's the graph of the solution, and then to write that in interval notation, we go parenthesis, negative infinity, comma, 2, bracket, because 2 is included, union, meaning, hey, we got more answer coming, 4, comma, infinity, and parenthesis. We always put parentheses around infinities when we're dealing with interval notation. And folks, that is the end of 1-8 for quadratics only. This also ends the last lesson before your first exam. So make sure you complete all of your homework assignments up through and including this 1-8 Part A assignment. In addition, make sure you complete your review assignment so you can take the test. The review is going to definitely make you ready for the test. All right? Y'all have a great day.